There is nothing simple about learning programming. Be it for fun or to enter into a new career, there's a lot to learn. This course is here to give you a gentle introduction to many aspects of professional software development. Most importantly, it will also introduce PyCharm. We will start by looking at techniques we can use to make the act of writing code smoother. Then we will look at some of the social aspects of software development. And finally, we'll introduce the concept of code quality and get more hands-on with writing clearer, more reliable code. Currently, grow out of the beginner's phase. If you're ready to discover key skills that complement programming and apply them with PyCharm, join me in this LinkedIn Learning course. What does it take to build software? As you may discover in this course, a lot. There are so many different things that we need to keep in mind. You need to think about how you're going to write your code, how you're going to run your code, how you're going to test and debug your code, how to deploy it, and so much more. There are many tools that handle each of these considerations, and the combination of all these tools make up what we call your development environment. Now, we could have created dozens of courses for these dozens of tools, but why not enjoy the benefits of one tool that integrates everything we need? These are referred to as integrated development environments, or IDEs for short. The IDE of choice for this course is PyCharm. We've chosen PyCharm for several reasons. It is beginner-friendly, it is applicable in professional settings, it's free, and it can support you throughout your learning professional journey. The professional version of PyCharm does support more specialized skills that you're likely to encounter down the line, but also JetBrains, the organization that creates PyCharm, also has similar IDEs for many different other programming languages. This means that if you like PyCharm, you will be able to transfer the skills you learned this course as you pick up new technologies over time. I challenge you to try and stick with PyCharm as you learn Python. Adopting a new tool can be frustrating, but there is no alternative to practice. It's okay to eventually shift to different environments, but make sure to give this one an honest try. This chapter is all about setting up the software we need for the remainder of the course. We'll start with the most crucial of them all, Python, the programming language we'll be using. Now, this may not be your first course with Python, so the first thing we should do is check whether or not you already have it, and if you do, what version of it you have. In order to do that, on a Windows machine, you can open the Start menu and then type CMD for the command prompt. Here you can type Python -V. Now, if you use a Mac or a Linux machine, you will want to look for the terminal, and then you can type this exact same command. Once we hit enter, one of two things is going to happen. In my case, I see that I'm currently running Python version 3.9.7. You may get a different number, a different version, depending on how recently you installed Python, if you have it. If you don't have it, you will pretty clearly get an error message here saying that your machine doesn't understand what Python means. Now, if you have Python version 3.10 or above, you are good. Feel free to skip this video and move on to the next steps in the course. If you have an older version or no Python at all, I will show you right now how to download it or update it. The first step here is to visit python.org. This is the official Python website and is a great resource for any aspiring Python developer. First of all, this is where the documentation for the language lives. It's very important and we'll be referring to it quite often throughout this course. This is also where you can start gain a sense for what the Python community is doing and the debates that are happening within. You can also get a glimpse into where the language is heading in the future and perhaps even contribute to those conversations over time. But for now, we're mostly interested in the downloads. As you hover over downloads, it should automatically pick up what your operating system is and offer you the most recent version. I'm going to click here and start the download. In the meantime, I'll show you if for any reason you want a different installer, you want an older version for historical reasons, you can find it by clicking on Windows, in my case, since I use a Windows machine, and then looking for the older releases. You want to look for the stable releases if for any reason you need them. my download is finished, so let's install Python. You can click on the installer. Now here, make sure to tick the Add Python 3.10 to path. Then click Customize Installation. There's nothing we need to do in this screen. And then here, make sure that the Add Python to Environment Variables box is ticked. Click Install. In my case, I do need to provide some PIN. You may not need to do that for your own installation. This should only take a few seconds. All right, we can close this screen now, and let's go back to our command prompt and see what Python-V gives us. And here we go. We have Python 3.10, and we're ready to go for the next step of this installation puzzle. Now let's address the elephant in the room, the software from the title of the course, PyCharm. Let's start by downloading it. In order to do that, open your browser and then go to jetbrains.com/PyCharm. JetBrains is the organization that creates PyCharm. And this website we'll go back to occasionally, and you should be aware of it as there is some very helpful documentation here. But for now, let's focus on our main mission, which is to download it. Click on the very prominent download button here. And now you'll be offered two options, the professional version or the community version. Now, everything we'll cover in this course is compatible with the community version. And I would recommend that we all go ahead and download the community version of PyCharm. Now, the professional version has additional features, as you can see here, that help with scientific development, so everything data science, machine learning, as well as web development with Python. Now, you can already do all these things in the community version. Nothing stops you from writing code that does this, but there are some features that make your life a lot easier in the professional version. This is something we'll touch on briefly towards the later part of the course. But for now, let's just go ahead with the community version, make sure that the correct OS is selected. I am on Windows, so I'll click download here. And the download should automatically begin. If not, feel free to click direct link. All right, so once your download is over, click on the installer, and we should have a pretty straightforward installation process. I am asked for some credentials, you may or may not. But once we get into the installer, let's click on next and next so far. So this is where you might have a few decisions to make. So clicking here, I would recommend you do that. You'll just put PyCharm on your desktop. It will be more accessible. It's up to you whether or not you want to create an association between .py Python files and PyCharm. This means that if you are using another tool and you already have some Python code, if you tick this, if you go back to those files, double click on them, they will automatically be opened in PyCharm, which, if you're trying to build up mastery over this tool and practice it, it might be a good forcing factor to get you used to it. I'll let you decide on this. Personally, I am going to click it. We'll hit next, install, and once again, through the magic of editing, we're going to fast forward through this lengthy install. All right, once it is done, let's choose Run PyCharm Community Edition and hit Finish. You will be greeted with a screen like this. Now, I've had PyCharm before, so it's showing me some of my older projects, but you will probably not be given these options, at which point I recommend you click New Project. You will have the option to name it. I will call it Tutorial 1. As far as the next options are concerned, you will want to click Keep Virtual Environment. We will cover this concept in Chapter 3. And in terms of the base interpreter, you want to make sure that we're using the most recent version of Python that we've downloaded. You can see it's already a little bit messy. I have a couple different versions of Python in my machine. But if you've been following along this tutorial, you will only have Python 3.10. Or alternatively, if you also have a few other versions, do make sure to look for Python 3.10 here. So we have the right version of Python being used by our project. Let's click Create. All right, so PyCharm will greet you with the tip of the day, which might be quite handy as you're learning the tool. I will disable them for the time being so that they don't distract us in the middle of our courses. and you'll be greeted with a basic Python file. Now, let's just make sure everything is working fine. You can click on this green button, Run, and we should see Hi PyCharm. Well, hello, everything is working. Let's go on to the next video to learn how to customize the UI of PyCharm. First things first, before we start looking at how to create code on PyCharm, let's make sure it is as pleasant and easy to use as possible. These IDEs are extremely customizable. If you go to File and then Settings, you'll see that many aspects of everything we'll cover in this course and beyond can be tweaked and adjusted. As we discover new features of the tool, I will point out any relevant setting changes that might help out. For now, let's focus first on accessibility settings, if you're in need of any. As you open the settings, go to Appearance, and then PyCharm covers a few different accessibility options. If you need screen readers, you can take this option and restart the application. You can also adjust how the overall application looks in case you have some kind of color vision issue. This is set up for red-green vision. It may not work ideally if you have any other kind of color challenge, but I'll show you some way to work around that in a moment. As we start looking into the editor settings, we'll be spending a lot of time writing code. Overall, that's one of the big pillars of what we do, as I mentioned. So making sure that your editor looks comfortable, doesn't tire you out after a few hours of work is important. As you go into the editor, one of the first things I always jump into is the font. I'm going to go ahead and keep the default font. I quite like it, but I will make it a little bit bigger so that it is easier and more readable for you and I. I'll go ahead and apply that setting. You might see in the background that things just got a little bit bigger. I am a big fan of this darker theme for the application and for the editor, but if you do not like it, there are a few other options that you can find in color scheme, from higher contrast ones to lighter ones. You can also further customize this. So as we dig into the color scheme, you can see that it affects so many aspects. It affects our console, it affects kind of the general application, it affects how Python is displayed. So every keyword in Python is highlighted in a different kind of color. It makes your code a lot easier to parse. You quickly associate a color to a particular concept, so you can quickly see, hey, this is a function, this is a keyword, etc. But either if you are the artsy type that wants things to look a particular way, or if you run into any issues with things not reading clearly enough and there being some confusion, you can change any and all of those colors. Simply look for the specific thing you want to change. So for example, if I want to change function definitions, you will see what kind of color is used here, and you can change it. Now let's look at our UI a little bit more. So when we run our code, you could see down here that we got some output in this console. You have also probably noticed the project pane here. This shows us everything that makes up our current project. You can see the main.py file that we've just run. You can also see this vem or VM folder. It's a little bit confusing, which is why we'll spend chapter 3 explaining where it came from and what it does. You can easily add new things to your project just by right-clicking here, creating new. If you want another file here, you can pick a Python file and let's do a demo.py, etc., etc. And you can navigate through this. We'll talk a little bit more about that next video. This is also fully customizable, so you can, if you'd rather have it here at the bottom, you can bring it to the bottom. You can just drag it. If you look for this project, you can drag it to whichever section of the screen you would much rather have it in. One final thing to share as we wrap up this video is that there will be a lot of information we cover, and it's very normal to forget about a particular thing. Now, it is quite helpful that PyCharm itself comes with quite a few helpful resources. So if you go to Help and then pick Learn IDE Features, you will be shown a series of tutorials on several concepts here. I would encourage you to take some time and go through some of them Perhaps after you go through these videos to help reinforce some of the concepts and also introduce you to some of perhaps the less common features, but still features that might interest you over time. Now it's finally time to talk about code. At the end of the day, you could use any simple text editor to write the code. Python will understand as long as you're writing valid Python. But many IDEs and code editors have specific features to help us edit code more efficiently. Let's put this into perspective. Over the course of your career, you'll spend thousands of hours writing tens of thousands of lines of code. This better be a comfortable process, as you're going to spend a lot of time doing it. Now, we'll cover a few tips, a few tricks that can save you a lot of time in the long run. After a bit of a learning curve, bear in mind that leveraging your keyboard is much faster than relying on the mouse. Now, I don't mean to say that you are not going to be successful if you rely just on the mouse. And really, there is a bit of a question here of, do we really care about this? Well, yes and no. The objective of this course is exposure. So I want you to be aware that these tools are available to you. Give them a try for a few days, see what sticks, see what feels helpful. But ultimately, adopt the things that are comfortable to you. You'll be okay regardless. If at the end of the day, mouse and keyboard is your way to interact with your code editor, and that's what you're comfortable with, you can still build up a very great career. Now, let's get into PyCharm and demonstrate some of this. Now, say we are writing a new part to our function, and we want to select a specific part of what we've just been writing. Now, we can obviously use the mouse, but I'll try and avoid doing that. As you're working on your code, your cursor will be moving along, and you can use that to select something. By pressing Ctrl W, you will select the specific word your cursor is on. This is handy. As you keep pressing Ctrl W, that selection is going to expand. So here we're now selecting the content of the entire string. Hitting Ctrl W again will include the quotes. Ctrl W again will include the parentheses, and you can get a sense for the logic. If you hit it one too many times, say we just want the string, you can hit Ctrl Shift W to move the selection back in. Now, as you are doing this, bear in mind that you can also hit Shift and right to select character by character, Shift and left to move the other way around. Shift and up selects the line above, while Shift and down selects the line below. Now, here is one handy shortcut, although it does rely on a little bit of finger gymnastics. Press Ctrl, Alt, Shift, and then J to select every occurrence of the word your cursor is on. So you can see that name is highlighted twice. I could now simply delete it and then rename it to what I would like. You can see that the cursor is in two positions, so I can type in two places at once. This is really handy, and to be honest, the first time I discovered this feature in a text editor, I lost my mind. You can trigger this kind of multi-line editing at will by pressing on the Alt key and then clicking wherever you want to be making edits, however many times you'd like. Now, when you start typing, it will be duplicated across all these cursors, and this can save you quite a bit of time. We've just been talking about selecting code. What are we going to do with it once we've grabbed it, once we've selected it? Again, a lot of handy things to check out here. Ctrl W to select this. I can press Ctrl D to duplicate it. If I select the entire line, Ctrl D will duplicate the entire line. That can save you a little bit of time as well. Selecting the entire line and printing Ctrl/ is another very handy shortcut as it comments it out. So if you've tried something, you want to remove some logic from your code, but you do not want to lose it, this is an easy way to keep it around. You can also use Ctrl-Shift-Up to move a line upwards, or Ctrl-Shift-Down to bring it back down. And you're probably aware of this one, but Tab allows you to tab it in. Shift-Tab brings it back one level. Now, hopefully, with this collection of shortcuts, manipulating your code is going to be a little bit smoother. You might be thinking, some of these are neat, but this is a lot. And it is. It does take quite a while to incorporate these into your workflow. So my recommendation to you is to really trust the process. Muscle memory will kick in after a couple days of deliberately using these. And my other recommendation is going to be to visit the link that we shared in the video description, where you can see this reference card. This is designed by the creators of PyCharm, and it contains a reference to many of the shortcuts we will cover and some more. I would strongly recommend, if you're serious about learning this tool, to download this and keep it handy, or perhaps even make it your desktop background so you can refer to it very quickly while you're working. After a couple of weeks, some of these things become second nature. Coding projects can grow very big, very fast. For the first few weeks of work, they might be quite manageable. If you're working on your own, they might be quite manageable for a bit. But as time passes, as more collaborators jump in, it's easy to quickly start facing dozens and dozens and dozens of files at several hundred lines of code each in different folders and modules, etc., etc. Basically, it becomes very quickly like a maze. And it will grow to the point where you cannot necessarily recall exactly where your code is. It just doesn't fit in one's head at any given point in time. So one thing that we should expect from our IDE is to help us navigate that complexity and be able to move around complex projects pretty easily. We will learn exactly how to do it. I have a project to show you that is still at a pretty medium size, pretty small size really. It is for a little game that we'll be seeing quite a bit of. So I have a game file, as well as the grid where the game takes place, and the cells that make up this grid. Now, I also depend on a lot of other code, but we'll talk more about dependencies in an upcoming video. So while we're only seeing these 3-4 files, there is a lot of logic behind this kind of hidden away. So if, like me, you often end up with dozens of files open at once, you have a handy shortcut available to you to kind of find a file and open it very quickly by pressing Ctrl-Shift-N and then starting to type the name of the file. So if I'm looking for my cell.py, I can just start typing it here, hit enter, and we'll open it. If I want grid, same thing. Now you'll notice you can't quite see the body of these various methods. That is because we have collapsed that view, which sometimes help just visually focus on what you need to be looking at. But you can easily expand this by hitting the plus sign and gain access to that logic. One other thing that can help in navigating one file is the shortcut Ctrl-G, which allows you to just give a specific line number and go check out what's happening there. So at line 49, this gets us into the draw method of the grid. This is how we display a grid, and the logic for it should be fairly straightforward. Here we have the draw method of the grid, which looks into all the rows of cells available to us. For each cell in this row, it will draw the cell. Now, say I'm working on this grid file. I'm trying to add some more logic to it. I'm trying to build it up, but I'm really quite curious how this draw method works, because I think I could use it for something else. I could go looking for it elsewhere, but again, PyCharm offers you something quite handy. With your cursor on a specific function or method, you can hit Ctrl-Q to fetch the documentation for that method. So you can see where it is defined, you can see its signature, and then whatever documentation statement the authors have written. You can even go beyond this. By hitting Ctrl-Shift-I, you can bring up the actual implementation of that method. So you can see it's called draw. Here is the docstring, and then it's a simple if-else that calls this particular sequence of code. So now going into the file itself, again, we can navigate pretty quickly, Ctrl-Shift-N, cell, and now we know we want to look at the draw method here. So Ctrl-F allows you to search within a specific file. So if we look for draw, we can see that the word draw shows up a couple times, but most pertinently, we have this function draw here. So searching can be very handy, again, navigating a big file. But since here we're trying to deal with projects, note that you can also search at a project level. So by hitting Control-Shift-F, this search now is happening across our whole project. You can change the scope of it. You can search within a specific module, within a specific directory. But in this case, you can see that the term draw shows up several times in cell.py, shows up in game.py, and a couple times in grid.py. Now, in a very similar fashion to searching across the project, you could replace a term across the project. So say, for example, we want to kind of change how we refer to this particular function. It's a little bit confusing. There are too many draws. We would like to call this something different. Let's call this one display cell or something along those lines. What you could do is hit Control-Shift-R to do a replace across the project. So looking for the term draw, we would like to change it to display cell. And then you can hit replace to change them one by one, or replace all to change all of them. Now, pause for a second and think about this. Is replace all a good move here? Well, you may have noticed that draw is used in very different contexts. We've defined a draw function here. We've defined another one in grid. There is this other draw here that we don't really know much about yet. And so replacing all of them to a new term would not necessarily be helpful. It might actually break some things. If this becomes display cell, who knows if this Pygame thing, whatever it is, supports that. So as you've seen in the UI, you could go checking each instance one by one, but there is an even better way of doing this. You can click on the token that you're hoping to replace, right-click, refactor. Here we will pick rename, and we can change this terms to display cell. And now PyCharm is actually going to go through the effort of checking the context for where draw is being used each time. It is quite accurate at this, but if you want to double check what it's doing, you can click preview. And here it will show you exactly where it thinks this specific meaning of draw applies. So the draw method is defined here, and then it is used in grid. In the draw method of grid, there's a call to cell.draw, line 49, like we've seen before. So this is a much safer way to try and do these bigger kind of editorial changes to a project. As we wrap this up, let me show you one final handy tool. By clicking Shift twice, you can pull up this general search interface. By hitting Tab, you can go through different kinds of searches. The first is classes. If you're looking for a specific class of a particular name, it will look for that. You can also look for files specifically, or more generally, symbols, which will also include kind of variable properties of objects, things of the sort. So you can move through these using Tab, Shift Tab to move back. Again, the keyboard allows you to do this pretty quickly. This final one, actions, not as relevant to what we're talking about, but allows you to actually search across all the functionality of PyCharm. Have you ever spent hours working on something only for your computer to crash and all your progress to vanish? Have you ever stopped working on a project for some amount of time and gone back to it and gone completely lost, not knowing what you were trying to do last time or how it even worked in the first place? Have you had friends try to jump in and work with you, and has it always seemed like a headache to get them involved? How can we be coding together? Well, these are very common problems, especially as you're getting started. Luckily, we're a community of builders, and so we've built some tools to help manage our work as individuals and later on as teams. These tools do a lot for us, and they fall under the category of what we call version control software, or VCS. In particular, they help us hit three very key objectives. First, they keep a record of the project. You can see how it evolved over time and easily roll back to previous states if you want to for any reason. In particular, this is possible because it backs up our project and many versions of it at that. So you should never worry about losing too much progress as long as you're using these backups frequently. And finally, they make collaboration so much easier as you can figure out who should jump into the project, and they give you many tools to make sure that we can all progress together without stepping on each other's toes. And we'll be covering these three pillars over the course of this chapter. Now let's make sure we get set up correctly. There are many version control software. We will be focusing on one specific one, Git. This is the Git website, git-scm.com. And I'm showing it to you particularly because the documentation here is really great. We will cover many of the key Git concepts, but quite lightly. And so if you want to go deeper, the official documentation is always a good resource. So you can go ahead and download this, but I'll show you a slightly better way, perhaps faster way of doing that, making sure that everything works out fine in PyCharm. So when you jump into PyCharm, go to File, Settings, then pick Version Control, open it up, and under that, pick Git. Here, you should test whether or not you already have Git on your machine. Perhaps it's there from a previous course, some previous work you've done. This will take a moment, and it might either tell you that you have Git set up or that you don't, at which point simply click Download and Install. It will take a few minutes, but you will be all set up just through PyCharm. So while this is working in the background, there is a second thing to cover. Whereas Git is the software that has all this logic of how do we keep track of our project, the various versions of it, etc. There are many places where you can actually save that project. GitHub, GitLab, Bitbucket are some of the most popular options. For this course, I encourage you to use GitHub, as it is widely kind of seen as the most popular option for this. So again, Git and GitHub kind of work hand in hand. Git can help you save your work in many different places. GitHub is the one I recommend we use for this course. So if you already have an account for GitHub, you're good. Otherwise, I suggest you come to github.com and sign up for an account. It's free, it's very straightforward. Get that done and come back to the video. So at this point, you should have Git installed, and you can see it here. Git has been installed. And you should also have your GitHub account. Now, in the settings page, under Git, you should see GitHub. Here, you will see that no accounts have been added yet. So let's go ahead and add our account. You'll want to log in via GitHub. This will open a new page in your browser where you'll be asked to authorize PyCharm in particular to be able to see your GitHub information and interact with your GitHub account. So once that is done, that's it. You should be able to come back here and get some details of your account. And we can now move on to some more elaborate features. Let's start a new project and see how to include version control from the get-go. We'll go to File, New Project. And for this one, I'll call it the structure practice. Hit Create. And now we have to explicitly tell PyCharm that we want this project to be tracked by Git. We can do that by going to VCS, Enable Version Control Integration. And we'll make sure that we pick Git. Now, quite a few things should strike you immediately. The name of our main.py just turned red, and a bunch of new buttons popped up in the top right of the screen. We'll cover what these various buttons do over the course of the next few videos. But if the red text is bothering you, don't worry about it. It simply means that this specific file, main.py, is not tracked by Git yet. Now, what Git does is that it tracks your project, the entire folder that it contains, but also keeps track of the individual files within it. And we need to explicitly tell it that we want it to watch the evolution of a specific file. This process is called adding a file. And you can do it simply by selecting the file, right-clicking, going down to Git, and then Add. And you can see now we have a much more pleasant and less alarming green title. There's also something that you'll have the option to do whenever you create a new Python file. So for example, if I create a file to do some list practice, then I'll be offered the option to immediately add it. So Git will be watching it. There are some scenarios when you do not want that. So if for some reason I'm including my super secret password in this project, I might not want Git to do anything with it. I don't want my password to be uploaded into GitHub where other people might be able to see it if my project is public, things of the sort. So do not always default to adding files. Think about whether or not they are worth sharing with others. You can also make sure that Git ignores some files or folders from your project. This is easy to do. Simply right-click, go to Git, and then add to Git ignore, selecting this first option. This will create a Git ignore file, which, as you've probably guessed, tracks all the elements that Git shouldn't worry about. And this is a more structured way, kind of a best practice to make sure that you can have some local files that are helpful for your development, but that they never go to Git. Anything you list in Git ignore will be ignored. Now, what is the point of this adding? Well, after you've done some work on files that are tracked by Git, you will want to commit them. This is important. The act of committing a set of changes is your captain's log, your journal. This creates a snapshot of your work. This is valuable as that builds up the history of your whole project, and you will always be able to bring back your project to the specific state you committed it in. Let's see how to do this. We can immediately commit by pressing this button. You will be shown an option for what files to include in this commit, as well as a message that you can add it to. Here I'll just say initial setup for the project and commit. Now we can see by pressing the show history button and going to log that we have this first commit message. This is the only commit in this project so far. I will now take a few moments to build up this project, and we'll go back when it has a bit of a meatier history. All right, back after a few minutes of coding, let's see how the project evolved. As we click on show history and then log, you can see now that since our initial setup, there have been 3 new commits. I've added 2 problems to list practice and tested them in main.py. And then I gave the list practice problems bare names, and I've added a new problem to reverse a list. Finally, and this is our most recent commit, I've added a set practice. Now, when you click on a specific commit, you can see exactly which files were modified when that happened. Moreover, you can see how this commit modified the previous state by clicking this button. This will show you that whereas I had problem 1 defined here, it is now called find max. Problem 2 is called list comprehension, and problem 3, which was just empty, now has been fleshed out. If we click on main, we can see how that evolved as well, where the calls have now changed to match the new names, and we are testing the third function that we just created. Now, we got a sense of all these changes by just reading the message. So the message is helpful. Just saying fixed the bug or did the thing is not going to help you nor your colleagues. So try and make your messages concise, but with information. Now, beyond this, one thing that's really powerful when you're dealing with bigger commits, bigger changes, particularly if you're trying to understand a code base better or trying to track a bug, trying to find when the bug was introduced, is that beyond this UI to show the difference, you can completely change the state of your folder to one of those previous ones. So if I go here, right click, and then check out this revision, you will see as we open list practice that we're back to having problem 1, problem 2. And you will notice that set practice has disappeared from the folder. You can see here that we are currently looking at this specific commit. And the folder will change accordingly, and if we run it, it will run this specific version of the code. Once we've done our investigation and learned what we needed to learn, we can get back to our most recent commit by right-clicking the latest one and then picking Checkout Master. All good. Hopefully, with these tools, you will be able to keep track of your progress as you do work and learn Python and go through more courses. This is a habit to build up that will serve you well in your professional career, but there is still much more to get, which we'll cover in the next video. Let's face it, coding is difficult. There's nothing simple about conceptualizing a solution to a hard problem, coming up with the design and going through the implementation of it. It takes time and it takes effort. And it's easy to feel like you're almost tripping over yourself as you go through that effort. Your project was once working and now it's full of errors, it's full of incomplete code, complete functions. You have all these ideas, but you're still quite a distance away from having a stable running project again. But that's what it takes to implement some big changes. And so it begs a question in a professional context of how can we have the best of both worlds? How can we keep a working version of our code at all times while also being able to break things and iterate on things? So the solution that the industry has come up with, by and large, is to rely on features like Git branching. So what's a branch? A branch is an alternate version of your project that Git can create for you. It has its own history of commits. You can iterate on it, develop a branch without affecting any of the other branches. But where it gets very powerful is when you realize that branches can ultimately be merged and combined back into one whenever you see a need for it. And so from this emerged the following practice of maintaining separate branches for your project, where you would have one main branch. This is the one that should be stable. It should always be working. And it will change from a team to the next, but typically it should see minimal development, if at all. This is not where you want to be trying the crazy ideas. On the other hand, you can have feature branches, where you'd be focusing on one feature or a small set of related features. And these can be broken for a little while. Hopefully not too long. We'll still try and keep our code as clean as possible. But, if you've been working all day, making good progress, but your code is not in a good place yet, you should still commit and push that and not worry about losing it. And ultimately, once you achieve the goal of the branch, you can merge those results back into the main branch. Let's see how to do this using PyCharm. So in PyCharm, I am back with the game that I showed you last video. And this time, let me actually explain how the game works. It's called Conway's Game of Life, and it consists of a grid. This grid is made up of many cells that can either be inactive, as you can see represented by gray, or active, as you can see in green. And there are some very simple rules that govern whether or not a cell becomes active or inactive, based on how many neighbors it has. So if a cell is active and has 2 or 3 neighbors, it will remain active. If it has fewer or more, it will shut down. Similarly, an inactive cell will stay inactive unless it has exactly 3 neighbors. The rules seem pretty simple, but they can create some really interesting and complex outcomes. For example, this specific pattern is called a glider, and as I click the start button, you'll see why. Applying these rules, it just kind of replicates itself and moves down the screen. Now, I've made some progress and implemented the fundamental rules, but there's still a lot of work to do. This reset button doesn't do anything. I can't click on a cell to try and turn it on and draw my own patterns. And honestly, this game doesn't look very good. Things aren't really centered. The colors aren't the best. So let's make some progress here, but using Git branches. So as I go into Git and then branches, you can see that I'm currently on the main branch. The first option in local branches indicates the branch you're currently on. You can see here that I've created another branch. I'll show it to you in a few minutes. But for now, let's create a new branch where I'll focus on the design of the game, just making it look a little bit better. So let's call it revised looks. This checkout branch option is quite important. Checking out a branch means shifting to working on that branch. So if I hit create with the checkout branch option ticked, I will immediately be on the revised looks branch and making progress there. If I turn this off, I'll create a new branch, meaning I've created a new version of my project from this current state, but I will not shift to it immediately. I will stay on the main branch. In this case, I will check it out and create. So if I go back to the same screen, you can see that I'm now in revised looks. You can also see that by going to Git here and seeing which of the branches is on top with this little logo. And now I'm going to fast forward, make some changes to how the game looks, and I will come back in a few moments to show you how to merge that progress back in. All right, I've been working on this for a little bit, and this is how our game looks like now. There is still some room for improvement, but I think overall it looks a little bit nicer. So let's see how to move all this logic over to the main branch. First, let's take a quick look to understand what exactly happened. As we click on Git here, you can see that main remains here, but all these new commits that have happened since belong to the revised looks branch. The revised looks is ahead of the main branch, and we're going to try and merge these changes in. So when you want to merge two branches, you're going to be merging the changes from one branch into another branch. So you want to make sure that you're in the branch that you want to bring the changes to. So let's go to main, since we want to update main with the new changes. You can do that by pulling up the list of branches, going to the one you want, and pressing checkout. Now, if I run the game, you will get the clearly uglier version of it. So we're going to change that right about now. So as we try to merge, you can go to Git, pick merge. Then you want to pick which branch you're merging in. We will go with revised looks, and then we'll click merge. And voila, this just worked. Now if I run this, you'll see that we get the updated look. As we look into Git, if you look into the history now, you'll see that main is now up to date with all these changes that were included. And this merge was very painless. It happened automatically because Git could tell that there were no major conflicts between the work that we were doing in our new branch and what was in main. But now, sometimes you will run into the need for doing a manual merge, or Git will clearly tell you, hey, I don't know how to resolve the difference between the two branches that you're trying to merge, so we need you to make a decision. And I'm going to demonstrate that by bringing in a merge with my event controller branch. So this branch makes the buttons work. It also makes the code quite a little bit clearer and kind of sets us up for some of the new features that are coming ahead. It still would not look very good, but if we merge this correctly, we are going to get the updated functionality from event controller, as well as the better looks from our main branch. So let me go ahead and try to merge this. And here you can see that there are some conflicts. You have a few options, right? So this screen will show you the files that are conflicting. You can either accept your files. You keep the current version of the file. You can accept the changes coming in, or you can perform a manual merge where you'll have to go through and make a decision on a case-by-case basis. And often, unless you really know what you're doing, it is worth going through this manually. So let's go ahead and do that. So you get this somewhat basic screen, but important screen nevertheless, that we're going to use to perform the merge. And I'll just show you an example of it. So here you can see what's happening in main And here you can see what's happening in event controller. And you can see that, hey, I actually went in and created some variables that have similar purpose, but different values, slightly different names. So this one is going to be a little bit hairy, but you need to make a few decisions. You can choose which change to bring by pressing this button. So in this case, I'm going to want to keep what I have in main because that has the most up-to-date visuals that I want. And I am going to keep going through this and choosing which change I want from which side of the screen, from which of the two branches. All right, so I finished my merge. Let's try and run this. And I'm getting an error, so I guess I made a mistake in my merge. This is one of the variables I introduced recently. I guess I didn't merge it in, so let me just go ahead and add it. So you always got to be careful when trying to deal with the manual merge. It's very easy to make simple mistakes, and we will, as much as possible, try and minimize how often we have to do this. So after fixing a few issues with the manual merge, we can run the game. And you will see that we have kind of the new design that we looked into. When we start, you can see that this turns into pause. We can pause this. You can actually now click and change the shapes here. Start, see how that evolves. And, well, you can also potentially reset to clean the screen. So we've successfully brought together the functionality from these two branches with a little bit of extra manual support. So far, through adding, committing, and branching, we have been saving our progress locally on our machine. Now, GitHub offers us space on the cloud to back up this work. It's quite easy to do this using the push command. Once you are ready to save your work, try to push every couple commits. It's a good habit to build up. Simply click on the green arrow up here to start a push. Alternatively, you can go git and then push. But see, here we are prompted to define a remote. What does that mean? A remote is a URL that will indicate to Git where to save your work. If you've been following along with these tutorials, you will have started from a local project. So we've never defined a remote up to this point, so Git doesn't know where to save our work. We can do that by going to the GitHub website and then selecting new to create a new repository. Here I'll call it push demo, and I'll just skip a description for now and create the repository. You will then want to copy this link and click on define remote here, paste the link, and we should be good to go. So Git can check what exists in this remote repository, and it can tell that there's nothing there. So all our commits from our initial one to our recent merge and the fixing of some of the problems I had after the merge will be included in this push. You can just click here, and after a few seconds, it should show you in the bottom right that the changes have been pushed. Now, if we refresh this page, you'll be able to see that all your code is now here, safe and ready to be shared with other folks as well. Do note, though, that only one branch has been pushed. You only push your current branch. So here we only see main. We will not see our event controller branch or the branch where we redesigned the look and feel of the game. You'd have to push those individually if you wanted them to be backed up as well. Now, what can be pushed can logically be pulled. This is crucial when collaborating. Pulling from the repository means asking GitHub, did anyone push new updates while I was away? Now, there are some considerations though. First, you pull information for your current branch once again. Not every branch will be necessarily in the repository. Secondly, as with merging branches, pulling may cause conflict with changes you've made, requiring a manual merge. And as I mentioned before, we are going to try as much as possible to minimize that. And let me show you some examples of how workflows can play out. So, say you are going to start working with someone else for the first time. There is not much point pulling anything if you're working alone on the repository. No one else is going to modify it. But Say you've done some work, you push it over to this remote repo. Now your colleague can clone this. This is the first step for them to create a copy of the project. And I'll show you how to clone in the next video. But you've pushed, it's available online, your colleague clones it. Now, after a little while, you go to bed. Your colleague is happily making commits, making changes, pushes an updated version of the code. So when you pull, you will get access to that updated version of the code. This is great. But now let's consider what happens in this scenario. You've made some changes, you've cloned it, your colleague got access to the repository. They went on to work on something. You went on to work on something. And now both of you want to push. What do you think is going to happen here? Pause the video and think about it for a moment. Now, this becomes a bit of a race. Who is going to push first? If your colleague pushes before you do, your push will be rejected by Git because it clashes with what your colleague may have just pushed. So you will now be forced to pull and do a merge. So if your colleague wins the race, you will now need to pull, probably do a manual merge to kind of create an updated version of the code that includes your changes and their changes, and now you can finally push it. But say your colleague is super productive and they've already made some commits and pushed it before you finished merging, you will once again be blocked. So this is a very tricky way of approaching this. You could kind of take turns, but that is not particularly effective. So what do you think the secret is here? You've probably figured it out. Branching. This is why branching is very powerful. You can just keep working on your own branch and not worry about interrupting somebody else's work with unnecessary merge. Work on your branch, push it, and finally merge in main when you are ready for that. It is hard to fully remove the need for merges, but with using branches, you can minimize it quite a lot. I would strongly recommend at this point that you start looking for other Git courses within our catalog, as well as visit the learngitbranching.js website, which is really fantastic at giving you some more practice with Git concepts and particularly visualizing this in more meaningful ways. See you in the next video for a challenge. There is a great deal of collaboration in our field, thanks to tools like Git and GitHub. In this chapter, however, we are going to look at a different aspect of collaboration, finding and leveraging open source code in our projects. This is something that can save you a tremendous amount of time. So let's start with the definition. What is open source? Well, it is software with accessible code, which is usable in projects free of charge. So you have the source code. You can modify it, read it, understand it, and no one is going to charge you anything for that. This movement spans across fields and has a long history. We're not going to get into the details of it, but a few things to bear in mind. This is not specific to Python and the Python scene. All programming languages have open source projects tied to them. Many technologies have it. In fact, it's not exclusive to software development either, as many other areas have adopted it. However, it is not a silver bullet, and it comes with some risks. Most importantly, the question of who maintains this software. Anyone can put together an open source project and put it out. Do you want to use that? Are there people still watching it, improving it? Are there people who can help you fix bugs that you find in it? Is an important consideration to bear in mind. Now, when should you use an open source project as a starting point for your own work? It's a good question. Fundamentally, the way I think about it personally is when I'm facing a problem, do I want or need to build the solution to it myself? For example, I want to build this game that we've been looking at over this course. I would not be interested in an already functional version of that game. But there are some things that I've needed along the way that I would rather just find and use, as it helps me keep my mind on what I'm trying to achieve. And now let me show you an example. Right now, what I would like to do is to have some music playing my game. I would like to look for a library. A library is just another word for a set of functions that have a specific purpose. So I would like to look for a library that will help me bring some music into my game. I have a little bit of music background. So what I'm looking for is really something where I can say, play this note, then play this note. That way I can have some fun trying to make a song, but I don't have to start everything from scratch and figure out how audio files work in Python, etc. So whenever you are looking for some kind of an open source project in Python, your first stop should be pypi.org. Well, you might just use the search engine, but this is an important website to be aware of. PyPI stands for the Python Package Index, and this is a repository of, as you can see, very many open source projects in Python. All these projects can be downloaded, brought into your own project, and leveraged as you are trying to build whatever you have in mind. So let me click on Browse Projects here and look around. There are many ways to search through here. I'm going to go through Topic and browse down until I find Audio. Here we have Sound Audio. In particular here under Sound and Audio, I'm familiar with audio format called MIDI. So I'm looking for a MIDI library. Let's take a look at this Melodia one. Here you'll be able to get a sense for the documentation of this library, any installation instructions. Usually if this is empty, it is not a good sign. You want someone to kind of communicate to you how this specific package works. Let's take a look at the example here and just very optimistically, we're going to copy it and bring it into PyCharm. I'm going to create a new file. So music demo.py. We'll add it to Git and we will paste this code, and immediately you should notice this red underline. It's telling us unresolved reference. Basically saying, I have no idea what you're talking about. What is this Melodia word? PyCharm, this current project, is not aware of what it is, but we have a solution immediately here. Click here and it will install the Melodia package from PyPI. I'll show you another way of doing it. You can click down on Python packages here. If you don't see it, you can also access it by going through View, Tool Windows, and then Python packages. And this will show you all the packages you already have installed. You can also search, and this queries PyPI. You can see you can find Melodia. We see the exact same documentation we've seen before. We can go ahead and install it. It takes a few seconds, and now we are done with that kind of error flag, the red underline. And we can try and run this, and it will generate an audio file. You can go ahead and play and get a sense for the music that was created. And so I still have quite a bit of work to do, but I'm a step closer to my goal. I can now kind of set up a specific arrangement of notes and create an audio file, and I can see how to bring that into the game. So you should always be on the lookout for any kind of open source library that will help you achieve your goal faster. And the collection of all these packages that we've downloaded to make our project work are what we call the dependencies of this project. It doesn't matter if we have cell.py, controller.py, game.py, grid.py. If we don't have access to these, this project will not work correctly. Hence the term dependency. We can get a lot more details about the dependencies of our project by going through File, Settings, and then Python Interpreter. Here you will see all the packages that make up the dependencies of this project. These are all the things I've downloaded over time. That being said, pip, setup tools, and wheel are dependencies by default for any project you create through PyCharm. These are very important tools to actually install other packages. Pip in particular is actually the tool that does the act of downloading from PyPI or potentially other repositories that new dependency that you need. Looking at the entry for pip, it seems to be a few versions behind. It's currently on version 21.1.2, but there's a 21.3.1. This is indicated by the triangle sign that you see here over in the latest version column. You can easily upgrade it by clicking here, then click in on this upgrade button. It will take a few moments and the upgrade will be performing in the background. And here we go. The package has successfully been upgraded. The version of the package that you bring in is quite important. Here you can see that Pygame, I have the latest version of it. But let me actually remove Pygame and bring it back. So here, when you click plus, you can search through packages. I'm going to look up Pygame. And here you have the option to specify which version you want to bring in. And there are a lot of versions of the software. I'll just bring back the version I had, but this begs the question, why wouldn't you want to just bring in the most recent version of the software? There are quite a few reasons. First of all, none of us are perfect, and it might be that the latest version introduces a new bug or worsens performance or gets rid of some functionality that you cared about. It might be that it requires you to upgrade Python to a new version or some other dependency to a new version that you're not willing to go ahead and do. So it's important to take these things into consideration. This is not the most glamorous part of the work of software development, but it's important to be aware of it. If you rely heavily on a specific package, I would recommend that you actually follow them. Either follow their GitHub repository or any other channel that they use to communicate with you. For example, here is the Pygame GitHub repository, and you can turn on notifications for it. You can follow along to see what kind of changes are happening there. If it's a crucial dependency to your project, it's important to follow along the developments of it. Now, one other thing that we care about is making sure that we can easily communicate to other people that these are the dependencies of our project. This can be achieved by documenting them in a file that in Python, the standard format for is requirements.txt. You can generate that file in a couple of ways. The simplest one is really just going to Tools and then Sync Python Requirements. This will ask you for a few options, but by and large, I wouldn't mess too much with these. And let's just hit OK. We created a new file, so we'll be prompted for adding it to Git. Let's go ahead and do that. And this shows us that we need Pygame and we need Melodia. So now if you commit and push this file, others will be able to refer to the requirements of the project and install them so they can run it. PyCharm makes this simple. If you check out a project with requirements, as you will in the challenge, you will immediately be prompted to download all the packages that are defined in this requirements.txt file. Let's take a deep dive into a very important concept for Python development: virtual environments. Recall that pip is the tool that actually connects to PyPI and downloads packages for you. Typically, when you install a new package through pip, it is made available global. Any project across your computer can access that new package that you just downloaded. In practice, as you work on more and more projects, this is not something to encourage. There are quite a few issues with this. First, it's hard to tell what a given project actually needs. Your requirements.txt file is going to be huge, as it includes everything you've ever downloaded for any work you've done. It's a difficult task to juggle different versions of dependencies. If one project needs a specific version, the other needs a different one. It's also risky because now updating one project's dependencies could potentially break another project. And so we use virtual environments. By creating and naming a virtual environment for your project, you isolate it from other projects on your machine. While this environment is active, everything you install through pip is only available within this environment. This isolation is considered a best practice in Python development because it avoids all the issues we had before. The only potential downside is that you might be downloading the same package multiple times, but frankly, that's really not a major consideration. So using pip within a virtual environment brings in local dependencies tied to just one specific project, and they are not going to clash with other projects. So what about virtual environments? How do I create one? How do I deal with this? Well, there are tools for creating and managing virtual environments. Typically use the console, the terminal, in order to set it up, activate it. But one of the perks of what we've been doing so far is that PyCharm has taken care of that for us already. So if you look here within our project, this VM folder stands for virtual environment. And within this folder is all the source code for everything we've downloaded through pip. So this VM folder, some people say Viv, this is where all the dependencies we've brought for this specific project live. And other projects should typically not bother looking in here. So if we go to lib, you can see here that in Pygame, this is all the source code for the Pygame package. We have Melodia, which we mentioned, we have pip, etc. We even have our own version of Python just for this. That's, I think, in the include folder, etc. You can also get some details about your virtual environment by going through settings, your project, then your interpreter. You can click here and show all. And here you can see kind of the various virtual environments. This little V sign indicates that this project uses a virtual environment. And you can see the various ones that have been created across projects I've worked on. But typically, you will want to pretty much always work within a virtual environment. PyCharm will give you the option not to use one when you create a new project. So you can use a previously configured interpreter here and not rely on virtual environments, but I strongly encourage you to stick to this moving forward, as it will inevitably save you a headache down the line. So far, we have covered many topics that support the act of programming. But in this chapter, we are going to refocus on coding in particular and ask the following question. What makes a piece of code good? This is a question that will accompany you throughout your career, and I propose that there are 3 elements of it, 3 things you should expect from good code. First, it correctly achieves its objective. Secondly, it is easy to read and maintain. If you're going to be spending weeks or months working on a project, you don't want headaches just trying to find your way around it. Finally, it is performant. In other words, running your code is not going to cause my computer to fry. So how do we get there? Well, to get to correct code, we should be seeking mastery of the language, and this is what you're doing by seeking these courses, etc. But we also should learn how to hunt down bugs and fix them, and how to future-proof our code through testing, and we'll focus on these. As far as clear and readable code, well, style guides come into play, and we'll cover them. Design best practices are also very crucial, but that is a more advanced topic than what we'll cover in this course. Finally, what about performance? Overall, this is a bit of a more advanced topic, as it involves really understanding the resources available to you and your machine and learning how to benchmark, so we will not go in depth into performance this chapter. Throughout this chapter, we will be working on this repository. I encourage you to check it out. It contains a more advanced version of Conway's Game of Life that we've been seeing so far. It will have specific branches to help us narrow down our focus on each topic. Feel free to read through the code, but you are not expected to know it inside out. The term bug has been used in our field for God knows how long. It's kind of unclear when exactly it started being used, but probably one of the funniest uses of it was from 1947 at Harvard. Back then, believe it or not, computers were easily the size of small buildings. And when a group of engineers realized that the computations being done by their machine came out incorrect, they went looking and found a literal bug, a moth stuck within the circuitry of the machine that caused the calculations to come out incorrectly. We will not be dealing with anything as disturbing as insects in our code, but we will be dealing with errors of many types over the course of the next few videos. First of which are going to be runtime errors, or errors that occur when Python does not understand a line you're asking it to execute. I'm currently on the 0402 branch. When I try to run the game, we'll see that it looks nice. But when I try to start the animation, we're hit with a wall of red text. Now, this can be jarring, but this is important. This is a learning opportunity whenever you are hit with errors. So this trace back shows you ultimately where the error occurred, but everything that led up to it. So this is telling us that when we call the display method, and this happened in game.py at line 103. Within display, we eventually made this call, which happened in game.py at line 81. Then this call, which occurred in grid.py at line 45. And then ultimately, this call at line 42. The final link provided will typically send you straight to where the error exactly occurred. The final line is important. This contains two things: the type of the error, which in this case is ironically a type error, and a message. The message can often be enough to figure out exactly what's wrong. In this case, we're saying that this method is missing one required positional argument. So we can look into our code. Issue is with this count living neighbors. So this method takes two parameters: a column number, which is an integer, and a row number, which is also an integer. But here, I, for some reason, only pass it the column index. So this should be something we can fix quickly by just providing it the row index. The information is here, I just forgot to type it. So let's run again and start, and we are good. But often, this won't be sufficient. So triggering the error again, the next thing you should do is start to build an association between the type of error you're facing and the kind of fixing that you need to do, the kind of debugging that you need to do. And your best resource here is the official documentation of Python. So if we visit the documentation for Python and look for exceptions, you'll see that there are many different kinds of errors that can be triggered. In particular, you should look for the specific error type that you've encountered and take the time understanding under what context these kind of errors occur. This can take time. It can be jarring when you are under a tight deadline, but this is a critical habit to help you more quickly deal with these kind of errors as they show up over time. Next, we'll move on to logical errors. More interesting and often much more difficult to solve are logical errors. These are not issues with your use of Python per se. Python will not be complaining. All the code you would have written is probably valid. The issue is when your program does not behave in the ways you believe it should. I am in branch 0403, which captures a pretty challenging logical issue I ran into in my early iteration of implementing the game. Let me run the code and show you. So we have a simple empty grid to start with. Again, let's make sure that we're on the same page about the rules, as I've just finished implementing the code that enforces them. First rule is that any active cell that has 2 or 3 active neighbors will remain active, it will survive. Any inactive cell with exactly 3 living neighbors will become active. And finally, all other cells in all other scenarios will deactivate. So I've just finished implementing these rules in code, and I would love to test them. So if I just put a single cell, well, it has no neighbors. So it should deactivate in the next step of the simulation. And that looks good. What if I put 2 of them next to each other? Well, this one has exactly 1 neighbor. This one has exactly 1 neighbor. That's not enough for them to sustain into the next generation. So if I hit next, they will both go away. So far, so good. The rules seem to be implemented correctly. But now what happens if I stack 3 of them together? Just think about this. This top one has only one neighbor, the one under it, so it should disappear. The middle one has 2 neighbors, so it should survive into the next generation. The bottom one, similarly to the top, only has 1 neighbor, so it should go away. So my expectation is that when I hit next, I will only see this middle one, and then if I hit next again, it will go away. So let's test it. Okay, all of them went away. So I must have some problem in the way I've implemented my logic. So let's first do a quick tour of the code as it stands right now. We have a cell class that is aware of whether or not the cell is active or not, and otherwise just has information for how to draw the cell. So it knows where to draw it, how big it is. But this attribute is the one we care about here. Grid is a much more complex class, but the crucial things to note is that it has the self.cells attribute, which keeps track of all the cells in the grid. Cells are organized in a nested list, a two-dimensional list. So we have list of rows, and for each row, we have multiple cells within that row. Then we have the update method, which is the one we care about here. So it goes through all the rows, and then from within a row, it goes through all the columns. And it then checks, using this helper method, how many live-in neighbors does the cell at this position have? And then we have a couple if statements. So if the cell is active and it has 2 or 3 live-in neighbors, then maintain it as active. If the cell is not active and it has exactly 3 live-in neighbors, then make it active. And finally, in all other cases, let's set it to be inactive. So this seems to be a pretty direct mapping of the rules that we spoke about. So I didn't make some careless mistake, put a 4 here or 20 here. There isn't a typo here, but we still have an issue. And we are going to investigate exactly what's going on using a tool called the debugger. So to debug your code, the first thing you need to do is set a breakpoint. A breakpoint is telling PyCharm when to stop the execution of the code and give you control over what's happening. What we need right now is information to try and understand where our implementation went wrong. To set a breakpoint, you can click in the space between the line number and the code editor. So I will set a breakpoint here. Now, if I try to run the game and set up my test scenario, hit start, nothing is going to happen. When you want to debug, you want to explicitly debug the game. You need to tell PyCharm that you are going to debug this, so you want to click on this icon. I'll set up the test and then go back to our UI, and we'll see that the UI has changed a little bit. The moment I hit start, our code is going to stop immediately before executing this line for the first time. Down here, you get a whole new UI to help you navigate the execution of your code. Remember, you are now in control. You now decide what happens next, rather than Python just executing your entire program. So here, first, we get visibility into all the variables that are defined by this point in the code. So our row index and column index are 0 and 0, which makes sense as we start navigating from the top left onwards. So this is the 0th row, the 0th column. And we also see the specific cell that we're looking into. You can click here to look at its attributes, and you can see that it is not active, which makes sense. This cell is not active. And now you can do a couple things. You can click step over to execute the next line and move on. So if I click step over, this live-in neighbors is going to execute. So for this cell, we expect to see 1 live-in neighbor. And you'll see here that we now have the live-in neighbors variable defined, and it is equal to 1. And then we'll go through these various if statements, and I can keep hitting step over, step over. And in that particular case, we shouldn't have changed anything about the state of that particular variable. And now as we're done, we're going to move on to the next step in the loop. And our column index will become 1. So we're now going to be looking at the cell 01, cell which is also inactive. I can click here to just let the program resume until it hits a breakpoint again. And I'm just going to do that a couple times until we get to the first cell that interests us, which is going to be the cell at row 1, column 0. All right, we're now at row index 1, column index 0. The cell that we have right now is active. This is this first cell. So we expect it to have exactly one neighbor and therefore to become inactive. So let's again step over, and you see that living neighbors is 1. So this looks correct so far. So what should happen to this cell? Well, it is active, but it only has one living neighbor, so we should deactivate it. So as you see, we do end up at this line 42. Here you could step into. This allows you to go into any function you're currently looking and see the details of its execution. So if I step into here, you'll see that again the UI changes. We are going to set the active property of this cell to false. Step over, and now we're back here. If we look at the cell, it is no longer active. So far, this seems to be making sense. Let's look at our next cell. Well, this is row index 1, column index 1. We're not particularly interested in this, so we'll once again fast forward until we get to the middle one. This is the one that is most curious for us. All right, we are now at row 2, column 0. This is this middle cell. That's the one that should have survived but didn't, and we should figure out why. So this should have 2 living neighbors right now. So let's call this function. But it tells me that it only has 1. And that's really odd because we can clearly see that it has 2. But if you recall, we just deactivated its earlier neighbor. We turned the cell off. We don't see it yet, but it has been set to be inactive. And so this might be where our bug is. The way the rules are enforced are that we should figure out all the neighbors first and then change the state of all the cells. So this approach is not going to fly. So yeah, that is the issue, and we're going to fix it in the next video. But hopefully this has gotten you a little bit more familiar with using the debugger to really get into the nitty-gritty details of what your code is doing. Last we left off, we had just tracked a very tricky logical bug where the neighbors of some cells were deactivated before we could count them. We used the debugger to find it. Now we are going to start taking steps towards fixing it, but we will discover some very important aspects of code quality on the way. So I've started making some changes to help us with this. First, in the cell class. A cell will have now a future state attribute. So we can store what the cell should become in the next step of the simulation without changing its current activation status, whether or not it's active. So we will have a set future state method that takes the number of living neighbors and decides the fate of the cell. And then we can, in a separate method, this update method, make it so that self.active is equal to self.futureState, right? So this assumes that we've figured out what your future state should be, and we're finally at a point where we're ready to change your current state to the future state. This function here is going to be pretty important for us. And before we get into it, let's pause and think for a moment. Wouldn't it be nice if in the future, if something went wrong with this logic of computing what a cell should become, that we would get an error message, similar to how Python complained when we called something with the wrong parameter or something of the sorts. You can achieve this kind of experience, but that is going to take some effort and require us to write some tests. Writing tests is easy in PyCharm. You can generate a test for a function, in a very straightforward way. You just go on the function and hit Control-Shift-T. This will create a new test for you. It will create its own file. It will have its own class name to run the tests. And it will set up a specific test function that will tell you a little bit more about in a moment. As we've just added a new file, let's add it together. Now, this is a simple unit test. Let's see what happens if I run this. And you will see that we get a slightly different kind of UI than what we've seen before when we try to run software. This is telling us that we are running tests. This is telling us how long the test took, only 20 milliseconds. And then the specific file, the specific class, and the specific function where the tests were called. In particular, here we have an issue, which makes sense because this test doesn't actually test anything yet. It just immediately fails. And we want it to fail because we don't want to be under the false sense that we have tests that are passing correctly. We haven't done anything yet. So conceptually, what is a unit test? It is a piece of code that tests a single functionality and asserts that it works correctly. In spirit, this is similar to what we've been doing in the prior video by setting up a specific scenario. Say, let's put together one cell and see what happens once we hit next. Let's put together two cells and see what happens when we hit next. We're going to try and do this in code rather than manually. And so whenever you think about putting together a test, a big chunk of it, and an aspect where you will grow your skill over time, is really thinking of what are the scenarios to test. In this case, this function is going to enforce the rules of the game, right? So we want it to correctly make sure that active cells with 2 or 3 neighbors survive. Inactive cells with exactly 3 neighbors become active, and everyone else get deactivated. Let's see how we can achieve this. This pattern is very common, and so we have libraries available to us to help us create tests. For this video, I am using unit test. It comes by default with PyCharm and Python, but there are many others, but they all follow fundamentally the same pattern. The idea is to first set up your test, right? So in this case, I want to test that an active cell with 2 neighbors will have future state equals to true. So the first thing I should do is create an active cell. So let's do that. Active cell is equal to cell. Now this is immediately underlined because I need to import the cell class. So I'll just go ahead and do that. And let's give it the right parameters for our constructor. If I remember correctly, we need to give it a position, dimensions, and whether or not it's active. Position and dimensions don't matter for this test. So just pass in 0, 0 for both. They shouldn't affect anything. But let's make sure that we say that this cell is active. Now I would like to call the function that I'm testing. So say future state and say that our living neighbors is equal to 2. And finally, let's make our assertions. This is the promise that this test is making. As long as the following statement is true, the test will pass, but if the following statement breaks, we are going to hear some complaints. So self.assert true. So I know how to use unit test. It has a lot of different assertion functions for different kind of scenarios. Here we're looking for a simple check. Is this Boolean variable true or false? And the Boolean variable I'm trying to check is active cell dot future state. So I can try and run this test now. And we'll see that it still fails, but now for a different reason. It wasn't hard-coded to fail. Now we see that we have an assertion error. None is not true, which makes sense if you think about it, because we are yet to define how this function should work. So nothing changed to our object, but it can be helpful to set up your test first, there's a whole philosophy called test-driven development that says that you should write your tests first because it will get you thinking about how your code should work quite in depth before going to implement the code. And your mission is going to be to make all these tests eventually pass. So let me take a moment and implement our rules in cell.py and see what happens to this test. All right, I've made some changes to set future state. So let's try and run our tests again. And we're good. It seems to have passed. So clearly we have correct logic, right? Well, not quite. Here's what I put instead of the future state. I just always make the future state true. This can't be good. This can't be enforcing the rules. So always be careful. If tests just pass, it is worth understanding exactly how your code works. A test can only show you that there is a mistake when it fails. It cannot prove to you the complete absence of mistakes. So clearly our test could be tricked. We are not considering all the scenarios. So let's see if we can improve this. So instead of saying that an active cell with two neighbors will have future state equal true, that's the kind of scenario we want to convey. A stronger statement here is that only an active cell with two or three neighbors will have future state equal to true. So let's keep our active cell and now go through all the number of possible neighbors we can have. You could have 0 to 8 neighbors. So for neighbor count in range 9, this variable neighbor count will have values that go from 0 to 8. Let's set the future state of this cell based on that neighbor count. If the neighbor count is equal to 2 or the neighbor count is equal to 3, we do want to assert that the future state is going to be true. But in every other scenario, we actually want the opposite. We want our future state to be false. Let's try and run this now. And this fails. But the way it fails is not particularly helpful. True is not false. Whoop-de-doo. If you click here, you can see exactly the line that failed. But it doesn't give us a lot of details into what specific scenario failed. You can improve that by adding a second parameter to this assert method call. You can give it a message that provides a little bit more detail, a little bit more visibility into what's going on. So here we can say that the message will only show up when the assertion fails. So we should describe the current scenario we're in. So here I'll say should be set up to remain active with neighbor count neighbors. And here I'll paste a similar string, should be set up to be inactive with that many neighbors. So let's try running this test again. All right, so here it's telling us that it should be set up to be inactive with 0 neighbors. So we failed on the very first instance with 0 neighbors because obviously we're making this true all the time. So let me pause one more time and try and improve this. All right, I have now brought back what should be now familiar logic. Let's try and run our tests. And we are okay. This seems to pass. But again, let's think about it. We haven't tested this scenario. So it worked out fine, given our test, that only in scenarios where an active cell with 2 or 3 neighbors did it have a future state of true. In all the other cases, it had false. But we haven't tested this. And so my challenge to you right now is to try and augment this particular test function to also test when an inactive cell will become active. One final thing as we wrap this up, the unit test documentation is crucial here. It has a lot of examples of how to use this, and you should get familiar with digging deep into this to understand exactly what you can do. In particular, having access to the list of assert functions is very helpful. In this page, you can see many of the simple assert cases. You can check for equality, inequality, you can check the type of specific variables, you can check whether an element is in a collection, so you have quite a few options here. So what is this talk of style in coding? Well, the same way the style of an essay can matter. The style of the code you write can have a big impact on readability. But before diving too deep into it, let's check out the 0405 branch for a little experiment. This branch has two Python files, example1 and example2. I would like you to pause this video and spend 5 minutes reading through example1 and write down what you think it will do once you run it. Don't run it. Just read it and do your best trying to understand it. And try to last 5 minutes doing that. Then let's look at example 2. Same thing. Time yourself for 5 minutes, read through, and write down your best guess as to what happens in example 2. Go ahead. We'll wait for you. Perhaps you are curious and you've already run them, but for those who've been patient and who have their guess, let's find out together. I'll run example 1 first, which seems to display a flag, then another, then another. Every second, it seems to be shifting between these 3 flags. What about example 2? Well, example 2 seems to be doing the exact same thing. So from a correctness perspective, both of these files seem to be achieving the exact same objective. But my question to you is, if you were to add new features or hunt a bug, which file would you rather work on? Example 1 or example 2? Example 2 is clearly superior here, as I'm hoping it was a lot more easy for you to navigate it and get a sense for what was going on there. You might not have understood everything. There are some tricky aspects to it, but it was a little bit clearer what the purpose of it was and where you would go to try and make some modifications. This is thanks to clearly named variables, to code that is grouped in logical ways so that lines of code that are next to each other typically try to serve the same purpose. There are some comments that help us address many of these of the more tricky lines of code. And, there is nothing as powerful as a well-named variable. Here, from line 7, you should already have in the back of your mind that we're going to be dealing with flags and we're going to be dealing with colors. You might not know what this symbol means, but this variable tells you that it has something to do with colors. And that's already teaching us something. Whereas example 1, I'm sorry if this caused any headaches, but this is not well-written code. So some of the recommendations I'm sharing here have some very practical purposes. Avoiding what we call magic numbers, so numbers that just pop up in your code, can really help you improve things. If, for example, I wanted to change this to be twice as big, I will only need to change it here. If I run example 2, we get our bigger flags, just like that, because we've defined variables for the size of the screen, and everything we have in our program works off of those variables. Good luck trying to get that same kind of result easily in example 1. If I were to change it here, which is the spot where the size of the screen is determined, things are going to look not quite as smooth. And I would actually have to make many more changes before getting the same experience. So there are some very practical benefits to this. Now, some of what I'm recommending here is very generic to any programming language, but there are also some Python-specific ways of doing things. For example, constants should be in capital letters. These are variables that will not change throughout the execution of your program. Nothing enforces that, but this conveys to your reader that, hey, this shouldn't be changing as you write more code in this file. These all stem from the Python community itself. In particular, one document called PEP8. So PEP8 is the official style guide for Python code. A PEP is a Python enhancement proposal. So documents that are generated from the Python community to try and suggest new features for Python, challenge the way things are done in Python. And PEP8 is the document that specifies what Python code should look like. And I would encourage you to read through it because many experienced Python developers follow this very closely, and it is an indication of your expertise often that you can write well-styled code. That being said, as the style guide itself says, the most important thing is consistency. If you and your colleagues and teammates have some reasons to deviate from this, and you're all consistent within your project and you're all happy with it, feel free to break from it. But it's important to remain consistent and clear. Now, there are a lot of rules here, but once again, PyCharm can help us out in a couple different ways. First, by going to File, Settings, Editor, and then Inspections. Here you can look for PEP8. And you'll see that you have the option to determine how PyCharm should react to coding style violations, which seems like a strong word, but it is what it is. You could completely disable them, which I do not recommend you do. But you can also set them up to be slightly stronger. And as you're learning to improve your Python, I would recommend you bump this up to a warning. As you edit a file, be on the lookout for the underlines here. So as you can see here, we see 23 different warnings. As you click here, you will see that many of them are PEP8 violation. And PyCharm can often fix many of them. You can hover over any of the highlighted issues and read exactly what's happening, at which point, for example, here it says that import statements should be at the top of the file as per PEP8. That way it's clearer at a glance to get a sense for what are the dependencies of a specific file. You can then click Reformat the file, at which point PyCharm is going to try and fix as many of these as possible. So if I undo this, you can see that a lot of the spacing issues, so this equals this mess here of commas. Once I reformat the file, this all gets a lot neater, but some of them you'll still have to go in by hand and try to address. And now for our final challenge of the course. You should check out the 0406 branch. This challenge will entirely take place in this branch. I have continued on from where we left off and actually implemented the methods in cell.py and grid.py that we had discussed last time. I've also added quite a few new tests for the cell class and also one new test for the grid class. Note one handy tool. You can put all your tests in one folder and then right-click and run. And unfortunately, everything fails. But you're probably not all that surprised. Your task for this challenge is to make sure that these 4 tests all ultimately pass, as they are failing right now due to a combination of runtime errors, logical errors, and sometimes just unfinished tests. This first test for the future state is fully implemented, but does not pass, so you will have to investigate it. This test update also seems to not be passing, although the logic behind it should be fairly sound. Test flip is hard-coded to fail right now, and it is up to you to think through how to test the flip method from the cell class. Finally, in test grid, we test the update method from the grid class. Once you get this method working correctly and you test it, you should be able to run the game and see the final version of this game. The challenge in testing this is setting up a test grid. So I've given you some comments here, some instructions on how to create a small grid, set it up in a way that makes sense, but is up to you to think through what test cases should be put in place and convince yourself that the update method works correctly or not. Finally, as you work through all these test functions, make sure that you keep in mind PEP 8 and good readability of code. Do note that throughout this exercise, you should only be modifying testcell.py, testgrid.py, and potentially, if you find some bugs, cell.py and grid.py. Everything else is set up so that it will just work once you have fixed these specific files. So no need to go digging into a controller or game.py unless you're done with the challenge and would like to try and understand the code as a whole. All right, let's work through these failing tests. We can run each test individually and get a little bit more focus in our work by clicking on these green arrows. It doesn't give us any more information, but it just gets rid of a little bit of the noise. So let's go through these test by test. First, let's run this guy and understand exactly what's going wrong. So we have a bug here. Future state should be true for 3 neighbors. This is happening in line 24. So this is the scenario where we have an inactive cell, and with 3 neighbors, it should bloom to life. Its future state should be set to true, but it is not the case here. So we have a problem. Let's try and debug it. I am going to set a breakpoint here. And similarly to any other code file, you can debug your test as well, which allows you to really pinpoint where things might be going wrong. So let's debug this. Okay, so right now we have our inactive test cell. Our neighbor count is 0. I'm just going to keep running this until we get to the point where neighbor count is 3, because that's the scenario where things are going wrong. Okay, 1, 2, 3. And now we're about to execute this line, but I want to step into it. Make sure that the setFutureState method does the right thing. So our first scenario applies only if the cell is active. Our cell right now is not active, so we're going to jump to the next one. So if you're not active and live-in neighbors is 4, okay, well, here's our problem. That would do the trick, wouldn't it? I must have made a mistake here. So we're going to be able to fix this. Let me just stop the execution, fix this, and then run our test again. Let's see what happens. And our test seems to be passing just fine. So that's one down. Let's keep going. Now, test update. So here we create a cell. We convince ourselves that the cell is inactive, which is what happens by default when you create a cell. Then we call update with some parameters, and these seem to be highlighted. It's already an issue. And then we want to assert, after the cell has updated, that it is now active. So let me try and run this. And first thing first, we get hit by a type error. We're calling update wrong. So with our handy shortcut, Control-Shift-I, let's look for the definition of this method. So update doesn't take any parameters, but it does quite a few things. So this test actually looks somewhat incomplete. So it assigns the value of future state to active and then resets future state. It just makes it equal to none. So let's fix the runtime error first and see what happens. So these shouldn't be here. And now we fail. We fail at this assertion because cell.active is not true. In fact, it is none. Again, let's look at the definition of update. Well, self.active was assigned the value of future state. Future state was then probably none. That's how cell.active evaluated to none here. So to make this test complete, And now that we understand how update works a little bit better, we should be setting the future state as part of this test. So our scenario 1 is going to be an inactive cell which will become active. So this cell, the future state, is going to be equal to true. And now once we update, we want to assert that this cell has become active. But remember, update does more than one thing. So let's also make an assertion for the second part, which is wiping out future state. So you might want to do some research into what kind of assertion to do here. So let's assert is. You can assert that cell dot future state is none after we've called the update. And this test seems to be passing. Notice that there are a few other scenarios we can be testing here. We might want to make sure that active cells can be deactivated, things of this sort. So let's go ahead and test at least one of them. So now we're gonna change cell to be a new cell. Actually, let me just copy this. But now set it to be active from the get-go. We will set its future state to be false. And now after the update, we can make some similar assertions, except now we want to assert false, right? But in this case as well, future state should be wiped. Let's run this. Still seems to be passing. So let's clean this up a little bit. I don't like this repetition here, so I'm going to rename some of these. So let's make this inactive cell. And we'll replace it here, 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 and here. And let's make this active cell, and we'll replace it. Which makes this a little bit more readable. And then let's add a few messages just in case this breaks. So future state was set to true, so the cell should become active. And then here we can also pass the message future state should be reset after an update. I'll keep the same message for the next test, and here we will have a very similar message. Voila, this looks a little bit better. Okay, so I have a page violation here, so it looks like I need a space here, I think. Good. And this is going to be our scenario 2, active cell which will become inactive. Now we can think of a few more scenarios, I'm sure, but I'll just leave it at this for now. Let's move on to the third one, test flip. So let's look at the flip method. Flip is easy. It takes the active value of a cell, flips it, and reassign it to the active value. So it should be a pretty similar pattern to what we have here. So if I create a cell, I'm just going to keep copying this. So we started with an active cell, right? So what I can do is call cell.flip, right? Well, I can assert first that the cell is active. Self.assert true cell.active, can flip it, and now I should be able to assert false cell.active. And now I have an inactive cell, so I could just flip it again. So now I should be able to make that first assertion again. So let's test this, and it seems to be running fine. So now, finally, time for the big one, test grid. So for this solution, I'm going to focus on the scenario we faced in the fourth video in this chapter, which was when we had one column of cells. So let's first try and set up that grid. So it's all in column 0. So I want 0, 0, 0, 1, and 0, 2 to be flipped. So what do we want to see after updating the grid? Well, this one only has one neighbor, so it will go away. This one had 2 neighbors, so it should stay, and this one has 1 neighbor, so it should go away. So this is the state that we're going to get into. So I want to make sure that all the cells follow this kind of pattern. Everything except the cell at 0, 1 should be inactive. So we set up our grid. We'll call testgrid.update. And now I should be making a few assertions. I'm going to remove this for the time being. I'm going to copy this a whole bunch of times. So 0, 0 should be false. 0, 1 is actually the only one that I want to be true. And then 0, 2 should be false. 1, 0, 1, 1, 1, 2, and then 2, 0, 2, 1, 2, 2. They should all be inactive. And it seems like I have a typo here. Yeah, I shouldn't be passing a tuple here. So let's fix this real quick. This is actually a good moment to use column editing. So I can just delete all of these and then move here, delete this. I forgot it in this last line. Okay, let's run our tests. We're very close here. And it didn't work. Okay. None is not true. So we looked at the active state of these, and it gave us none rather than a true or false. That's odd, but that's kind of familiar to one of the issues we faced only a few minutes ago. So let's take a look at the update method in the grid class. So update seems to be going through every row and the cells, and then every cell in the row, and then updating. But that is not what we said this method should do. It should first compute the future state. So there seems to be an issue here. So let's call self.compute future states first, and then try again, because this is when we set the future state of each of the cells. We now have a different issue that I did not expect. So everything seems to be fine up till 1, 1. This is the cell in the center. I expected it to remain inactive, but it's saying that it's actually active. So let's think about it. The cell in the center actually has 3 neighbors, and this is one of the rules that we set for ourselves. If an inactive cell has 3 neighbors, it should be active. So our expectation is actually incorrect. This shape should turn into this. We made a mistake in the previous video. And if you were one of the folks who caught it and commented about it, kudos to you. But yeah, our expectation is a little bit flawed here. And we shouldn't be changing our test or our rules to make it work, but let's rather change this assertion to true. This is what should be happening. And let's test this. And to wrap it all up, with all these tests passing, let's just double check, run all the tests. They all pass. With all our tests passing, let's run our test one final time. Thank you so much for trying out this challenge with me. As we come to the end of this course, let's take a moment for a quick recap, and most importantly, to figure out what could be next. In Chapter 1, we got more acquainted with PyCharm, the first IDE of many of you. Practice makes perfect, so I would encourage you to bring it along in future Python courses you take. Once you spend several weeks using PyCharm, then I would challenge you to perhaps try and change a few things. Try and use a different IDE, change up your environment a little bit, and make up your opinion about what kind of ways of working you like. In chapter 2, we spent time with Git and GitHub. We covered some of the very fundamental functionality in both, but there is still much to learn. If you haven't done so yet, I would strongly encourage you to visit learngitbranching.js, as it is one of the best tools I have found to visualize what's really happening when you use Git. I would also encourage you to look for more specialized courses on Git, and over time to try out some of the alternatives to GitHub, such as Bitbucket or GitLab, and again make up your own opinion of what kind of workflows work for you. In chapter 3, we covered the fundamentals of dependency management. And while as you adopt new tools, the ways you interact with dependencies might change ever so slightly, the basics of using pip, PyPI, and virtual environments will remain unchanged. A potential next step on this front, though, could be to learn how to create your own packages. And I encourage you to keep an eye out for ways to contribute to open source projects that you use yourself. This will double as some good practice on how to use version control. Finally, code quality, our biggest chapter. Correctness is one of the key pillars here, and you can get better at finding correct solutions to problems by studying algorithms and data structures. You can also study design patterns because they help tremendously in organizing our code better. When it comes to readability and maintainability, we focused on PEP 8 in this course, which is important, but design patterns fundamentally help us think about how to structure our code. So this is a very important area to cover. Testing is also complex. We did a quick overview of it, but I would urge you to look for courses focused on testing as well. Finally, there are no two ways about this. Practice, practice, practice solving problems, increasingly more complex problems with Python. Your comfort with the language is really crucial over time, which transitions us to the idea of specialization and looking into more specific fields. In particular, web development and data science are two very popular fields that leverage Python quite strongly. This also helps us answer the question of whether or not you should consider upgrading PyCharm to the professional version. If you pursue web development, taking courses on Django or Flask, or if you look into data science and use tools like NumPy, SciPy, or Pandas, it might be worth getting the trial version of professional PyCharm to see if those features really make a difference. Finally, as many of you are looking into entering this field professionally, I would like to share a final recommendation. I believe readiness to enter the professional sphere really stems from three things. Mastery of the language. So whatever language you are going to put on your resume, you should feel very comfortable with it. So keep on practicing Python. You also want some kind of track record of collaboration, hence jumping into open source projects, or at least working with a peer on Git on projects that are on version control that you can show. And finally, seeking a relevant specialization that is pertinent to the job market. Again, things like web development, data science are very popular right now, but who knows, by the time you're watching this, one might be crucial. At the intersection of these three families of skills, I think you will find yourself ready to face interviews, face applications. So all the best in your journey.